Hello everyone. Today I want to present the inter-data connectivity with MPLS VPN. Okay. Actually, this PPT was done by one of my colleagues, but he could not come today. Okay. Let me introduce a bit by myself. Okay. I am Dong Feng. I am a senior system engineer in Huawei Technologies. I'm located in Nanjing, China. Okay. Today's PPT will cover the following topics. First of all, we will have an overview. Then I'll talk about the MPLS VPN building blocks and Openstack operations workflow and L2 Datacenter Interconnect use case and regarding proposals in this area. And last, I will give the summary and key takeaways. There's a need for inter-data connection, because nowadays the cloud is composed of multi-data centers environment. These multiple data centers will share resources which are geographically distributed, and the tenant networks will span multiple data centers. Maybe in one data center the cost of electricity is sometimes cheaper than another data center. In this situation, there might be some VM live migration from one data center into another. During this situation, there should be need of automatically migrate the VM from one data center to another data center and set up the network configuration automatically. MPLS technology enables deployment of L2 and L3 VPNs. This was used in traditional networks, and it has proven queues guarantees and network resiliency. And it has also got the seamless movement of workloads such as VMs across data centers. And it can provide optimal placement of large flows data backup. We can have a backup LSP, and we can use ISVP to guarantee the queues, the bandwidth, something like that. This slide will talk about the MPLS VPN building blocks. For the inter-data connection, we would have the Openstack as a controller and orchestrator. In this is just to illustrate. In the data center 1, there might be VM1, VM2. In data center 2, there might be VM3 and VM4. All these VMs are connected to the customer edge, which is CE. CE is typically a user equipment, maybe a router or something like that, or a firewall. These CEs are connected to PE, provider edge, which is typically owned by service provider. The service provider will establish the tunnel between the PEs. If there are multiple data centers, the tunnel might be full mesh. Here to illustrate, I just use 2 data centers. The tunnels can be configured statically, or it can be the MPLS LSP can be set up by LDP protocols or static configured or ISVP protocols. The MPLS VPN service is between the PE and PEs. How CE can access the VPN? We would have an attachment circuit. This attachment circuit will connect a CE to PE. How we can use it inside OpenStack framework? We need to do the neutron API extension to support this feature. And after providing the OpenStack extension API, the workflow would be like this. We would create attachment circuits in each tenant network, and the attachment circuit would be treated as a logical interface. In L2 networks, there could be represented using a set of VLANs, or different VLAN represent a different tenant. And we can create MPLS LSP tunnels This step is optional. Like I said before, if you are using dynamic tunnel protocols like LDP, label distributed protocol, or ISVP, something in the network domain, then this step is optional. After creating the attachment circuit here, and attachment circuit and the tunnel, now we can do the third step, which is create a MPLS VPN service using the specified attachment circuit and LSP tunnels. The connectivity between attachment circuits in different data centers using LDP tunnels, or LSP tunnels. Sorry. Okay. The form mesh of LSP is by default with MPLS resiliency enabled. Okay. If there are multiple data centers, there would be a form mesh, which means if there are 3 data centers, data center 1, data center 2, data center 1 to data center 3, data center 2 to data center 3 would have their unique MPLS tunnels. And we would support during VM migration or movement, or also no deletion and server consolidation, there might be the forwarding table change. This we would use make withdraw for faster convergence to make the traffic or flow can go to the right destination smoothly. Oh, sorry. Okay, this is the L2 data center interconnect use case. Okay, this model will support both L2 and L3. In the L2 scenario, we would use the attachment circuit, which would typically maybe a sub-interface on the PE interface, PE physical interface, which representing a set of VLANs. Okay, the VM1 and VM2 belong to a certain tenant. We should use VLAN encapsulation for the tenant network. Then we say that this VLAN should be incorporated in the PE attachment circuit. Okay, and the LSP tunnels is established before, and we can use we create an MPLS VPN service using that attachment circuit and tunnel. If it is the L3 scenario, then it is also okay. But here maybe we need a BGP to advertise the connectivity between the different networks. Okay, the proposals in this area include Edge VPN, which is initially proposed by Broket, Mr. Hanif, and Huawei. And Neutron BGP VPN talks about there should be the BGP speaker, inside each BGP speaker inside each hypervisor. This is BGP or inside each computer node. The BGP speaker would advertise the network, which would be the 32 bit prefix, advertise the network on the computer node, or the IPs of VM on the computer node. And we will another blueprint talks about MPLS VPN as a service, which is more complex. Okay, we in the coming Liberty release, we are focusing on the BGP VPN. There are around Design Summit will talk a lot of things in this area. I think maybe in the coming Liberty release, it would be it would land in the trunk of Neutron. We are contributing to this area. And the summary and key takeaways. Okay, and MPLS VPN would enable you to add new applications and service quickly and cost effectively. Say that there are some cost difference between different times in different geographically distributed data centers. Then user can dynamically migrate VMs to the low-cost area. a network would be set up ready for the migration. And we can create a tenant network which spans multiple data centers using Openstack. VMs may move to physical servers, which resides in different data centers. And we need neutron APIs to provision L2 and L3 MPLS VPNs. And BGP auto discovery is to discover remote peers, highly dynamic and reduces menu configurations. We can use orchestration control and can be carried out using central or distributed Openstack client. Okay, I guess that's all for today. Thank you all for coming. Thank you.